Hello and welcome to another episode of Continuous Improvement, the podcast where we unravel the complexities of the tech world, one bite at a time. I'm your host, Victor, and today we're diving into a topic that's crucial for anyone involved in machine learning and statistical modeling, regularization. We explore what it is, why it's important, and focus on three popular methods: Lasso, Ridge, and Elastic Net Regression. So, let's get started. Regularization might sound like a complex term, but it's essentially a technique to prevent overfitting in machine learning models. Overfitting is like memorizing answers for a test without understanding the concepts. It might work for that specific test, but not for any other. In machine learning, this means a model performs well on training data but poorly on new, unseen data. So, how does regularization help? Imagine you're training a model. It learns from the training data, but also picks up some noise. Regularization adds a penalty term to the model's loss function, which is like a guiding rule for the model. This penalty term acts as a constraint, simplifying the model and making it less prone to overfitting. Let's talk about the first method, ridge regression or L2 regularization. It adds a penalty equal to the square of the magnitude of the coefficients. Think of it as gently nudging all the model's features to have a smaller impact. The tuning parameter, lambda, controls how much we penalize the coefficients. A higher lambda means more shrinkage, leading to a simpler model. Key features of ridge regression. 1. Uniform shrinkage of coefficients. 2. Great when many features have a small or moderate effect. 3. It doesn't do variable selection, all features are included. Next up is Lasso regression, short for least absolute shrinkage and selection operator, and it involves L1 regularization. The difference. It adds a penalty equal to the absolute value of the coefficients. This means Lasso can reduce some coefficients to zero, effectively selecting the most significant features. Key features of Lasso regression. 1. Can eliminate less important features completely. 2. Ideal for models with numerous features where many might be irrelevant. 3. Leads to sparse models where only a subset of features are used. And lastly, we have Elastic Net Regression, a hybrid of L1 and L2 regularization. It's especially useful when dealing with correlated features. Elastic Net has two parameters, lambda, which is common with Lasso and Ridge, and alpha, balancing the weight of L1 and L2. Key features of Elastic Net Regression. 1. A mix of Lasso and Ridge properties. 2. Excellent for correlated features. 3. Adjustable to mimic either Lasso or Ridge depending on the alpha parameter. So, how do you choose the right method? Ridge is your go-to when you don't need much feature selection. Lasso is perfect for identifying key variables. And Elastic Net. It's ideal for a mix of these scenarios, especially with correlated features. In conclusion, regularization is a powerful tool in our machine learning arsenal. Understanding Lasso, Ridge, and Elastic Net and their applications is key to building robust and precise models. That's all for today on Continuous Improvement. I'm Victor, and I hope you found this episode enlightening. Join us next time as we decode more tech mysteries. Until then, keep learning and improving.